Namaste, and a very warm welcome to today's explainer. I am your teacher, and today we're going to tackle a really brilliant topic in mathematics together, mastering pie diagrams. Now, whether you're trying to understand huge sets of data from the news, or you just want to make your own presentations crystal clear, mastering pie diagrams is an absolutely essential skill. We are going to take our time today, going step by step, so that by the end of this session, you'll be completely confident in both reading these diagrams and drawing the actual mathematics behind them. So, let's jump right in. Created by Mindsticks Foundation Trust. Here is our quick agenda for today. 1. Introduction to pie diagrams. 2. Reading a pie diagram. 3. The math behind them, central angles. 4. How to draw one. And 5. Real-world applications.
Section 1, Introduction to Pie Diagrams.
You've likely come across these circular charts before in your geography or science classes, right? Take a look at the proportion of land and water on our Earth. You really don't need to read a massive paragraph to understand it. You can instantly see that the water, represented by that large blue-pink sector covering 71%, takes up the vast majority of the circle. It's the exact same for the constituents of the air we breathe, mostly nitrogen at 78%, followed by oxygen at 21%. In a pie diagram, numerical data is neatly packaged inside a circle, and the different components are shown as proportional sectors. It just makes complex data so simple to grasp, doesn't it?
Let's move to Section 2, Reading a Pie Diagram.
The real beauty of a pie chart is how it feeds us vital information at a single glance. Let's look at the first diagram here. A survey was done with 120 Standard 10 students asking about their favorite games. Instantly, which game is the absolute favorite? Well, you can immediately see the largest slice belongs to cricket at 37%. You can also quickly spot that 10% of the students prefer kabaddi. Now observe the second diagram showing a school's annual financial planning. You definitely don't need to be a chartered accountant to see that the biggest chunk of their budget, exactly 45%, is strictly reserved for educational equipment. Our brains just process these visual proportions so much faster than staring at a boring table of numbers.
Section 3, the math, central angles. Now, to truly master a pie diagram, we absolutely must understand the concept of a central angle. Imagine a perfect circle, and right in the middle is its center point, which we'll call O. A central angle is simply the angle formed right at that center. Its vertex sits exactly at point O, and its two sides are formed by the radii that stretch outwards to the edge of the circle. In our pie charts, every single data component gets its own sector. And here is the golden rule to remember. The measure of this central angle is strictly proportional to the number of scores in that specific component. Let's look at the core formula that makes this whole thing work. You'll definitely want to note this down. The measure of the central angle, which we call theta, equals the number of scores in your specific component divided by the total number of scores. And then we multiply that entire fraction by 360 degrees. Now, why 360 degrees? Well, because a full, complete circle is exactly 360 degrees. By using this formula, we're just finding out what fraction of the total data belongs to our specific slice, and then calculating that exact same fraction out of the 360 degrees of the circle. Very logical, right? Section 4, how to draw one. There's a very systematic procedure to draw a pie chart accurately, and if you follow these steps, you will literally never go wrong. First, you have to understand that your whole circle will be divided into sectors that are proportional to your data. Second, you take your raw data and find the measure of the central angle, our theta, for each and every component using that lovely formula we just discussed. And third, you take your compass, draw a circle of a suitable radius, and then use your protractor to carefully measure and map out each sector, one by one, until the entire 360 degrees is perfectly filled. Let's look at an example to make this crystal clear. Please focus your attention on the bicycle shop example on this slide. This shop purchased a total of 36 bicycles of various colors, and we need to draw a pie chart for this. Let's look at the white bicycles first. There are 10 white bicycles. Our total number of bicycles is 36. So let's apply our formula. We take 10 divided by 36 and then multiply by 360 degrees. Now, if you simplify this, 360 divided by 36 is exactly 10, and 10 multiplied by 10 gives us exactly 100 degrees. So when you draw it, the slice for white bicycles will have a central angle of 100 degrees. You just repeat this exact same process for the black, blue, gray, and red bicycles. And notice this. The total of all these central angles will always add up perfectly to 360 degrees. Section 5, Real-World Applications.
Of course, in the real world, we rarely deal with just 36 bicycles, do we? We deal with large populations and massive data sets. Notice this pie diagram here. It shows the classification of skilled workers in different fields across an entire town. We have sectors for agriculture, production, construction, hotels, and others. Sometimes you're given the pie chart and the total numbers, and you actually have to work backwards to find the specific data points. And the brilliant thing is, the mathematics works perfectly in reverse, too. If we know the central angle, we can uncover the exact number of workers hidden right inside that slice of the pie.
Let me pose a direct challenge to you right now. Imagine you're working for the town municipality. You're handed this chart, and you are told that the total number of skilled workers in the town is exactly 10,000. My question to you is, using only the pie chart, how many of those workers are specifically in the field of construction? Think about how we might apply our central angle formula in reverse to figure this out. Let's solve it together using the figure on the screen. Look closely at the pink slice labeled construction. The central angle given there is 72 degrees. Now, what does 72 degrees actually mean out of a full circle? Well, it means 72 out of 360. If you divide 72 by 360, it simplifies beautifully to the fraction 1/5. This tells us that exactly 1/5 of the entire town's workforce is in construction. So, to find the final answer, we simply calculate 1/5 of our total 10,000 workers. 10,000 divided by 5 equals 2,000. So, there are precisely 2,000 construction workers. Do you see how beautifully the logic flows? By understanding central angles, you aren't just looking at a pretty picture anymore. You are unlocking the exact numerical truths hidden within the data. Mastering this mathematics empowers you to visualize, analyze, and truly understand the data that shapes our world. So the next time you open a newspaper or watch a news report, ask yourself, what hidden numerical truths are waiting for you to unlock them? Thank you so much for learning with me today.